Hello again, this is John. I'm going to talk to you today about the PJ5 CPU and about this board, which is the Fake ROM board. So, what we originally planned was to have a board which just had some ROM chips on it. So this is the board we'd originally planned to use, and we actually got it made up, and it has spaces on there for 3 ROM chips. Each of them is 8-bit. Because we have a 24-bit data bus, 24-bit instruction bus. So we were planning 24 bits out there, and it's got a 16-bit address that comes in here, and it's a really simple board. The address comes in, it goes to the ROM chips and comes out. The ROM chips actually have more than 16 bits of address line. They actually have another 3 bits, so there's a little 8-way switch there, so you can pick which. You could pick 8 different programs, for example. The problem with this, there's a couple of problems with this. One is that the ZIF sockets I bought don't fit, and the other problem, thank you Banggood, by the way, for sending me parts that don't fit, and the other problem with this is that the ROMs I bought are PROMs. They're not EPROMs or EEPROMs. They cannot be erased once they've been programmed. This is a slight oversight on my part. So we might keep that, we might use that at the very end when we have a final program we know we're not going to ever want to change. Although Murphy says we know we'll definitely find a bug we need to fix about 10 seconds after we program it onto the right one's PROMs. So for now we have this loader board, this fake ROM. All it is, it's a teensy microcontroller which has a USB hooked up to a computer at the moment. It has some level translators, so there's 2 8-bit level translators on the address input coming from the program counter board, and there's 3 8-bit level translators on the 24-bit data bus. That gives us a total of 40 interesting pins, so 16 in and 24 out. The teensy has 42 IOs that are useful, digital IOs. So there's 2 left over. Oh, and one of those is for the onboard LED, so you can't really use that. So there's 1 left over. So you can just about, on a teensy 4.1, it just about has enough pins to do this. So all it does, it runs a very little Arduino program that reads the 16 inputs and looks up the address or calculates the data we want to send out, and then outputs the data on the data bus. So we can do this with just a 64K table of data that we programmed into it on the computer when we write the program and upload it to the teensy. There are plans in future to make it slightly better than that. There are some buttons on the board, and there's a mode switch, and there's a little display. The idea being you press the button, some of the pins get disconnected from where they're currently connected to and get hooked up to the display and the buttons, and then you could perhaps choose between various files that have been preloaded on the teensy, or we could put files in on an SD card and select which one to use, that sort of thing. But we've not written the software for that. The software we've written now was a quick half-hour, let's just write some code that reads from an array and sends it out. So yeah, that's it. This is our fake ROM board. It's a really useful debugging tool. We've tried today several different programs on it, and it's been really useful, and it will continue to be useful as we add more boards and want to quickly knock up quick hacky test programs.